This is the multiplication property of equality. This is exactly what we did before with addition, but now we're doing it with multiplication. If you're going to multiply one side of the equation, you have to multiply both sides of the equation. Okay? Just like the addition property. So this is exactly the same slide as before. When I made it, it was exactly the same slide. I copied that addition property of equality and I erased the plus signs between it. So if you take this and you multiply both sides by c, it's still the same thing. Okay? So if you multiply one side, you got to multiply both sides. This is the process. This is the process to solve most problems in my class. You do this exact same process, you'll get it right. Most of the problems in my class, if you do this, you will get it right. First thing we do is distributive property. So we look for parentheses. Okay, once we get rid of the parentheses, we combine like terms on each side of the equal sign. So one x, or one variable, and one constant, or one number on each side. So one x and one number on each side of that equal sign. Once we have one x and one number, we move all the x's to one side, and I personally do the lower amount. You've been taught to move it to the left. I just undo the lower amount. Then we undo the addition and subtraction, what we did last time, and then we undo the multiplication and division, what we're doing this time. Okay? So first thing, let's rewrite this, make it look like a fraction. So 5 over 2x, 15. So what we want to ask is, what is happening? What's happening to the x?
It's getting divided.
It's being multiplied.
But you put it on both sides.
It's being multiplied, so how do we undo multiplication?
You multiply that number by 2 over 5 on both sides.
So we divide by that fraction, but you don't divide by fractions, you multiply by the reciprocal. Okay, if you remember on the homework, it did ask you what the reciprocal of something was. Normally those easy problems at the end tie into the next day. So that kind of stuff will show up again if it shows up at the end of the homework. Those cancel. We can make this 15 over 1. So x equals 30 over 5, which needs to be simplified to x equals 6.
I remember this.
Okay. Later today, I will show you an easier way, well, a way that I think is easier to do this problem. But right now, multiply by the reciprocal.
We're trying to do the next one.
Yep. It's your turn.
Mr. Rankin, didn't you use some PCA?
No, my wife did, and my mother-in-law does, and my brother does, but I never did.
You rebelled?
Yeah. Okay, if you want to look, I'm working it out up here, but I'm working out a little slower than hopefully you should be.
Is it 20?
Should end up being 20, yes. So that's 4 times 5 is 20 over 1 times 1, which is just 1. So your answer is 20. Okay? Every single problem where you're solving for x, every problem that's an equation with an equal sign, you should be able to plug it back in. You should always be able to plug it back in. On the test next Friday, on the test, you should be able to plug it back in and tell me how many problems you missed as you're turning it into me. You should know how to do that. Okay? Okay, remember we're always asking what's happening to x. So what is going on with x now?
Oh, we have to divide it.
Why do we have to divide it?
To figure out x.
But why? Why division?
Because you have to, you're dividing.
Because you do the
cancel
opposite.
You have to cancel the 3. The 3 is being multiplied, so we're going to take it and divide both. If we divide, we get x equals negative 11.
Why did you cancel? Can't you just divide on the other side?
If you divide the negative 3 by a negative 3, it turns into a 1. So they cancel out.
Disregard it and just you just do the other side.
I am disregarding it by canceling it.
Why go through all the work by crossing it when you can just ignore it?
Even this is a pointless one.
Sorry.
It's not a lot of work to draw a line through it. That's what I'm...
She does this a lot.
Okay, divide by 8 because x is being multiplied by 8. So that is x equals what? Negative 12.
See, I don't know fast.
Okay, the next one, there are 2 ways that you can do it. Somebody want to tell me one way that you can do this?
You can 7 over 1 and do the reciprocal.
Okay, so you can do the reciprocal like we did on one slide ago. The other way is think about what's happening to x. X is being divided by 7, so we can take both sides and multiply it by 7. Which actually is the same thing as multiplying by the reciprocal. You're just going to have a little more 1s put in there that don't need to be there. Like we'd have 7 over 1 and 1 over 7. So I just do multiply by 7 because those cancel out because you undid them, and that's 140.
X equals 20 over 7.
No, because you're not dividing. You're undoing what's done. So you're multiplying.
20 times 7, so that's
Yep.
140.
140. Okay, why does this slide look worse? What looks harder about this slide?
Decimals.
Decimals?
There's equations, expressions on each side of the equal sign. Because -2 divided by 5.
Because the number.
Well, yes, but this is a fraction. We just haven't written it down. So the decimals and fractions. So the next section, I will show you something optional that will make it a lot easier. It is optional, but it will make it a lot easier to do these harder type questions. No, I'm just writing these out. So you all try and work all 3 of these out for me. Okay, let's work out these next 3. So x is being multiplied by 3.1, so we're going to divide by 3.1. You should be done with this problem. So what does x equal?
1.6.
1.6. Good. Okay, the next one, we have a fraction being multiplied. So how do we do that? We divide by that fraction, which is multiplying by the reciprocal. Yes, it's 3/5 because we have 3 over -2. These cancel out. This -2 and this -2 can cancel. So then we have x equals 3 over 5. Okay, also our negatives canceled there. Last one, this one's going to be a bigger fraction. We multiply by the reciprocal. So you can see we've done by the reciprocal about 4 times already. That means it's probably important and probably on a quiz or a test. Okay, I usually repeat problems when you're going to see them a bunch.
Is that -12 over 35?
-12 over 35, and that cannot be simplified.
It doesn't matter the negative number.
It does not matter. The main one that I would prefer you not do is on the bottom, but it still is correct on the bottom. Most of the time we either have it on the top number or outside the entire fraction. Okay, remember, when you are solving equations, when you're working them backwards, you're going to work them backwards of what you normally would. SAD M. Okay, SAD M is just the opposite of PEMDAS, because when we're doing PEMDAS, we solve in this way. When we're doing solving equations, we're unsolving it. We're undoing stuff, so we undo it in that direction. So you undo the subtraction and the addition before you undo the division and multiplication. Okay? So what thing are we going to undo first on this one? The 4, because it's being subtracted. And we undo the subtraction and addition first. So it's being subtracted, so we're going to add 4 to both sides. Negative z equals 10.
Miss Hickenbach wouldn't be proud because you didn't rewrite.
Oh, yeah.
Rewrite what? Oh,
Yeah,
the
because she was like,
the chunka
"Y'all
chunka?
rewrite in Mr. Maxim's class?"
Yeah.
And I'm like, no. Well, like, I was like, I don't
When I
even
was
know.
in 6th grade, I used to like it all.
Rewrite, that's just chunka chunka, right?
I never did it.
Yeah.
Yeah.
Yeah. So we would do that, except I think it's easier to see that we're subtracting, so to undo that we add, instead of thinking add a negative and subtract a negative. Okay, so this negative 1 is here, so what you're actually going to do is divide by negative 1, and it's going to cross out, so z equals negative 10. Nope, you can just swap the negative.
Well, we don't have to show any steps.
Okay? Alright, next. This is where we start with that process. So the process says, do your distributive property first. Do we have any parentheses? No. So our next one is to combine like terms on each side of the equal sign. So first let's combine these.
Negative 5b, right?
Okay? Chunkadunka.
Oh, right here.
We have negative 5b equals... There's no other b over on this side, so we'll just write down 2b. And then we're going to combine our numbers.
22?
I think it's 21. Is it 21? Or is it 22?
Well, no, it's 22. Right?
Somebody type it in. Y'all have calculators?
22.
I just remember from last class it being 21. Unless I'm thinking of a different problem.
It is 20.
It's 21.
It is. Okay. Next, we subtract our lower amount of variables. But in this case, we have an entire...
Well, it's negative 5.
Negative 7.
Right. Negative 5 is lower. But we have an entire side that already is variables. So we're actually going to subtract this time. This is a rare special occasion where we already have the entire side b. So we're going to move this over as well.
It equals 3.
I'm so excited.
By the way.
Okay? So minus 2b, minus 2b. No, you undo the lower amount of variables in my class. So in this case, that's the higher amount of variables that you're undoing. And the answer is negative 3. B equals negative 3 because we divided both sides. Okay?
Wait, what was the answer? You scrolled up.
Negative 3 because we divided by a negative 7.
Number 4, do you have to distribute the property?
That is always our first step. Our first step is always to distribute. Okay? We don't have distributive property. All the terms are combined on each side. So now we're going to move our lower amount of x's. Which amount of x's is lower, 5 or 7?
5.
So we're going to undo that positive 5. Minus 5x minus 5x.
Can we actually write that?
The answer is 6.
Nope. Equals 9. We're going to add 3 to both sides. 2x equals 12. Divide by 2 and divide by 2. X equals 6.
Who's doing your eraser?
Okay? Number 4. Number 4, remember we're following that same step process every time. So our first step is to distribute. Distributive property.
Well, x plus negative 8.
So 12x minus 8 equals negative 1 plus 4. Yes, you can skip that step and write 3. I'm just trying to follow the exact same process. So we did distributive. Now we can combine like terms. You can see that there are 2 numbers over here, and we want a max of 1 of each.
X equals 1.
So I don't remember 1 being an answer, but maybe it is.
So is
It's
circle
11
number
over 12.
required or like?
It's not required if you can see it without it. Like here, I didn't do it, but you can. You can make it negative 8. So we're going to add 8 to both sides. If we add 8 to both sides, we get 12x equals 11. So we divide by what's next to x, and we get x equals 11 over.
I want 3 plus 8 is 12.
Yep, I've gotten a couple people with that. Okay, do number 5. Exact same thing as the one before. Okay. That's true. Okay, so that's 10x. 10x plus 15. I'm going to combine like terms in the same step. Okay? So if you want to do it in 2 steps like we did the time before, we can. But I combine like terms. Subtract 15.
Are you listening to the potato song?
Is that the Friends theme song?
No, that's the potato song.
Potato song?
I know there's a potato.
Oh wait, where's the what?
Why are you watching potato?
I did it reverse. I should make sense. I did.
It's the website makes us use that on it.
But you want to get all the numbers on one side and all the letters on the other.
Hey,
So if there's already all letters over here, you want to move all the numbers over here.
you can't start on your homework yet.
Okay, we're not done. We still got another slide.
No. Thank you.
Okay, remember we want to move all our letters to one side and all our numbers to another.
I'm good.
Okay? All right. So this one tends to confuse people a lot. Please listen, and I promise it shouldn't be confusing. It should be very simple. Okay? It says if x is the first of 3 consecutive integers, express the sum of those 3 integers in terms of x. Okay? So it says x is the first of 3 consecutive integers. That's what you want to look for. In the problem, you want to look for what it says here. 3 consecutive integers. It doesn't give us a single number. So how are we supposed to do this? We're going to make up our own numbers. And we're going to choose the easiest ones. What are the easiest 3 in a row numbers?
1, 2, 3.
1, 2, 3. So write those down. 1, 2, and 3. Okay, it says the first of those is x. So if 1 is x, how would I tell you what number 2 is? X plus what? X plus 1. Yeah, you could think x plus x, but then we couldn't do that on number 3. So how do we express 3? What is that going to be? X plus 2. So now we got some numbers, and now it says that we want to express the sum of those numbers. So we're going to take those numbers and add them together.
6.
Yeah, apparently. Alright, so now that we have that, we need to express the sum. We know how to combine like terms here. We've got 3 x's plus 3. And there's our answer. Okay, it's very simple once you write down your own numbers. So let's look at the next slide. I already have it written down up here, so let's erase it. Okay, the next slide, all I wrote down was 2 odd, but it's that same question, but instead of saying 3 consecutive, it says 2 odd consecutive integers. Okay, so what are the easiest 2 odd consecutive integers? 1 and 3 are the easiest. You could use 3 and 5, but let's use the easiest ones. Okay, it also says integers, so we could technically use negatives as well. Integers are whole numbers and their opposites, but negatives make stuff harder. Okay, if 1 is x, what is 3? X plus
2.
2.
It's 2x plus 2.
And then we want the sum of those, so there's 2 x's plus a 2. Does that seem pretty easy?
So is it 2x plus 2? Oh, okay.
Okay, very simple, but that tends to get people all the way. I mean, I had seniors last year that struggled with that question because you don't just start by making up the easy numbers. Okay, you start trying to think of what numbers they could be talking about. Okay, just pick the easiest ones. Alright, so solving linear equations 2.4, we're going to tie everything we've talked about together and then make it a little bit harder with fractions. Okay, so we're doing that same process, the process that I wrote out last time for you. It had these 5 steps below it, but I'm throwing in 1 step at the beginning. Okay? 1 step before the distributive property is to multiply both sides by something. Okay? With fractions, it's the LCD. With decimals, it is the longest decimal, and I'll explain that when we get to it. Okay, but if you multiply both sides by something, it'll get rid of the fractions. It'll turn everything into whole numbers. If you multiply both sides by something, it'll get rid of the decimals. Everything will turn into whole numbers, and it's a lot easier. So let's look at the first one. Okay, let's go ahead and write this out. X over 2 minus 1 equals 2 over 3 x minus 3. Okay, everyone, get on the notes. Get on the notes. A lot of people are just looking around. Okay, I'm telling you, this is going to make it easier, but if you miss part of it, it will make it a lot harder. Okay, so if we ever see fractions in a problem, if we ever see fractions, what we want to do is get rid of those fractions. Instead of finding common denominators and doing stuff like that, what we want to do is do this and get rid of the fractions completely, so we don't have to go over to the side and find a common denominator. Okay? We don't want to do that, because if we minus the fractions, we'd have to get a common denominator, and that takes more work. So what we want to do instead is get rid of the fractions. How we get rid of the fractions is we multiply by the least common multiple of the denominator. What can I turn everything into that is a denominator? 6. So we're going to take everything on here and multiply it by 6. Okay, and the reason we chose 6 is this. Okay, before you start doing that, you do not multiply denominators. You multiply just the top of everything. Okay, so we're going to distribute this 6 in. So 6 times x, 6 times negative 1, 6 times 2, and 6 times negative 3. So that's going to be 6x over 2 minus 6 equals 12 over 3x minus 18. Okay? Anybody confused at how I got to that step?
Wait, I'm still trying to.
No, I don't know how you got the 6.
The 6, I figured out the least common multiple of all my denominators.
Oh, okay.
So in this case, I had 2 and 3. Both of those can turn into a 6, so that's what I'm going to multiply.
Wait, Mr. Mason, do you know Daryl? Coach Daryl? He used to work here.
Not no deal. Okay, so the reason we did that is because it turns everything into whole numbers. If it doesn't turn your fractions into whole numbers, then something went wrong. Okay, so that 6 over 2 now just turns into a 3. So 3x minus 6, 4x minus 18. Now that's a simple problem. Okay, what is our step? What do we do next?
Well, you subtract 3x.
We subtract the lower amount of x's, right? Okay, this is the first time we've actually done this in class, where we subtract the lower amount of x's to the right side instead. Okay, so this looks a little different than what you would do because you were taught to move everything to the left.
So confusing.
Okay, we subtract that. We have negative 6 equals x minus 18 plus 18.
Yeah.
Equals x.
12 equals x. And it's okay that that's in a backwards order than you normally would have it. That's okay. Okay, what is confusing? Because somebody said it's so confusing. What is confusing?
So much work.
It's always going to be a lot of work. From now on.
Okay. Sorry. Go
Yeah.
ahead. You go.
Okay, so let's look at the next one.
Stop attacking me.
So 3 over 5x minus 2 equals 2 over 3x minus 1. Okay, the most common mistake on this is not giving it to each part. So make sure you give it to each part of this. Remember, it's still distribution. What am I going to multiply this whole thing by? What can I turn 5 and 3 into? 15. So we're going to take the entire thing and distribute a 15 to it. Remember, that is correct. Yes, and I'm actually, in just a second, those of you that feel pretty good about this method, I'm going to show you something that will make it a little bit easier to do, a little more in your head. Okay? I'm not recommending everyone do it, but Let's write down. Okay, so this turns it into whole numbers now. What's 45 divided by 5? It's 9 minus 30 equals 10x minus 15. Okay, so if you think this is pretty, it makes sense, which some of you do, I can tell. Okay, if you think this makes sense, I'm going to allow you to skip this step here. Okay, if it doesn't make sense, do not skip this step, or you're going to make a huge mistake. If you think this makes sense, let me show you what will make it easier. Instead of doing 15 times 3 and then dividing it by 5, you can divide first. 15 divided by 5 is 3. 3 times 3 is 9.
That makes so much more sense.
15 divided by 3 is 5, times 2 is 10.
I've been doing this that whole time. I didn't do that. So.
You can divide first, and then you don't have to deal with bigger numbers like 45.
You just said that first. That would make so much sense.
Because most people have to write this step down. Most do. I don't like writing that step down, but most do. So, okay, let's continue to solve this. The rest of this you should know how to do perfectly. We should know these steps on this part. So minus 9x, we're subtracting our lower amount of x's, so we don't have to deal with a negative x. Negative 30 equals x minus 15.
So we add 30. No, we add 15.
Add 15. We're getting x by itself.
Why is there so many parentheses?
We don't.
Because I couldn't make that fraction, so I'll write it out and make it look
So
easier.
negative 15 equals x.
Negative 15. Good. Okay, so now let's look at the next one. The next one looks a little different. Okay, I have rewritten it. So first rewrite this for me. Rewrite it. There should be one less set of parentheses and it should look more like a fraction.
Oh gosh, why?
All it is a fraction, and we can get rid of fractions. It makes it a lot easier. So write it down like this, and now we know how to get rid of the fractions.
Oh, okay.
No, it's not that bad.
Write it down. Write it down. Okay, there's only one fraction in this entire problem. So it's very easy to figure out what our least common denominator is. What's our least common denominator?
3.
3, because there's only one denominator. So take everything and multiply it by 3. Okay, here is a rule that you need to hear. So if you're working ahead, you need to pay attention right here. If you're going to do this method where you get rid of the fractions, we never distribute to stuff inside of other parentheses. So when I distribute this 3, I give it to this 2, and to this 6, and to this 2. I do not give it to this stuff inside. The reason is because later we're going to distribute to that anyway. And so it's going to distribute into that from this 2 later. Okay? Those of you that wanted to do the easier way, remember you can divide first and make 1 times 2.
Wait, so it's 6,
Uh-huh.
8, parentheses, a plus 3,
Uh-huh.
parentheses, over 3.
Yes. And then you can simplify your fraction just like we have been. And remember, you have to multiply everything. So over here it turns into 18a plus 6. Okay, now our fractions simplify. That's always that second step. So 6 divided by 3 turns into a 2. So you can see how that turned exactly back into what it was. Because if we divided first, it would look like that. 18a plus 6. Distribute. Yep, because remember, our first step is always to get rid of those fractions. So some of you wanted to distribute here. Distributing is our second step. Our first step was to get rid of fractions. I wrote that wrong. Make sure you write down 6 instead of 3 there, if you were copying me. Okay, so we subtract 2a minus 2a. 6, 16a plus 6 minus 6 minus 6. That's 0 equals 16a. Divide 0 by 16. What's 0 divided by 16? 0. If we take nothing and we divide it into 16 parts, it's still nothing. It's just 16 sets of nothing.
Oh, wait.
Yep. Okay, you're going to do number 4 on your own. See if you can get to the answer. I don't remember what the answer is. I think I know what it is, but I'm not sure. So try and work it out. Okay, I have rewritten it up here for you so you can see it a little better. Try that out. Okay, I'm going to start working it out. If you're not done yet, just don't look up yet. But I'm going to...
Oh, no, wait, what?
You got to divide.
Yeah, then it's 3.
It's either 3 or -3. I can't remember which one. So we multiply everything by 3. Don't multiply the parentheses. So skip over the parentheses. So that is 12y plus 3 over 3 equals 15y minus 21. That's 4y plus 3, 15y plus, minus 21. 4y plus 12, 15y equals 21. Move your letters to one side, so that's minus 4y. And I'm actually going to move my numbers to the other side in this same step. So plus 21. Okay, so those y's cancel over there. Those numbers cancel over there. Something's wrong. Oh, no, it's not. 11y equals 33. I do not get a negative, so that is positive 3. Did anybody else get positive 3 there?
I didn't even.
Good.
Wait. When can I retake the quiz? Because I'm not going to be here during advisory.
We only have 20 minutes.
Well, we have like a week and a half before the test.
Oh, okay.
Right? So you got a long time. Okay, so that's how you get rid of fractions. Remember, you want to find the least common denominator. If there are multiple fractions, then find the least common denominator of those. If it looks crazy, there's a problem on the homework that people are freaking out about because it looks like this. 1 over 10 parentheses 3x plus 5 plus 3 over let's not do 10. Let's do 3 and 5, and then there's more parentheses over here. 3x minus 8. People don't like that one because it's got a bunch of stuff, and you can see this is why you need to get rid of fractions before distributing. Some of you wanted to just use the fractions, but if you get rid of the fractions, then you don't have to distribute a fraction. So, see why that makes it easier now?
Yes.
You don't want to use the fractions for the math. You want to get rid of the fractions, then distribute.
But I like.
Yeah, but fractions make them. So, a decimal is the same thing as a fraction. Okay? A decimal is exactly the same thing as a fraction. What is this called? What place is that 5 in? The hundredths. The reason it's called the hundredths place is because that's the same as 25 hundredths. That's where that fraction comes from. Yeah, so that's 1/4. But we don't have to turn it to a fraction. We would rather turn it to a whole number. So what we're going to do is look at the biggest decimal. And not the biggest value, just the longest decimal. Which one goes to the furthest place value? Hundredths, hundredths, hundredths. All of them go to the hundredths. If one of them went to the thousandths, then we would use the thousandths. Okay? But all of them go to the hundredths, so that's what we're going to multiply by. 100. If we multiply it by 100, it'll get you to whole numbers again. Okay? Just like before, skip over the parentheses. So we don't multiply it by that 22. That gives us 25x, 10, x minus 3. Yep.
What if it's 1,000?
Then all of them will go to whole numbers. It just, some of them will change a little bit. Like if this one was to the thousandths place, then this would be 100 and this would be 250. You use your calculator to distribute. But you just do it to the biggest decimal. Okay, once you do that, then it's just easy numbers. Easy numbers. And I think this ends up getting x equals 4. because you'll do 140 divided by 35. But from then on, it's just a regular algebra problem that we've done. Okay? But that's once you've gotten rid of the decimals. I know that some of you will be like, well, I've got a calculator, why can't I just use decimals? You can, but it's easier to change it. It's much easier if you look at it this way.
It's not easier.
Yes, it is. It is. Okay? So, same thing here. What do I multiply everything by? I'm skipping ahead for some of you. What's the biggest decimal? That one's to the hundredths place. That's to the hundredths place. That's to the hundredths place. So what do I multiply by? Hundredths. We multiply by the biggest place value.
Is that on the first problem too?
Yep. On the first problem, the biggest one was the hundredths place. So we're multiplied by the hundred. If the biggest one was to the thousandths place, we'd multiply by the thousand. So distribute that in. And then solve that equation. I believe that one, doesn't it end up being like 0 divided by 44 or something? Yeah. It should end up getting 0 on that one. I am going to skip ahead after I write down the new step, because I think the old steps you're getting pretty good at. So, just to save time. Okay, the most common mistake, I've said it already, is distributing to the parentheses. Do not distribute this to the parentheses, because it's going to be distributed with that 9 and with that 3. Okay? And this ends up being 0 divided by 44, which ends up being 0. So this goes here, and here, and here. But it does not go to the parentheses.
Can you get a decimal for your answer?
Wait, look.
You can, but you don't.
Oh, and 1. I'm getting rid of the decimal.
Wait, 3 just multiply everything out.
I'm confused. How do you get 0 so fast?
Let me solve it. Okay, we got 35. X plus 9x plus 36 equals 36. Subtract 36 from both sides and combine your like terms. So I'm combining a couple of those process steps. This cancels. That equals 0. And that's 44x equals 0. Combine by 40, or not combine, divide by 44, divide by 44, and we get x equals 0.
Well, how did you get that so fast though?
I was just writing down the answer because we know how to do that process. I didn't do it in my head. I just wrote down the answer.
Oh, okay.
Right.
Five. What? 35.
Are these problems false? That was negative 30, because if you did 10 times negative 3.
Okay, negative 30.
And then
So you add 30 to both sides. So 25x.
No, you have to do
25x.
Oh.
That's why. You forgot to write down your variable. Okay, go ahead and solve this number 3. There's no decimals and no fractions, so you should be pretty good at this one. Go ahead and try it out.
That's how you do it. I think I skipped it.
Close, but I would not skip those steps because you made a mistake. So show every step, and then I can show you where. Okay, these last two problems, if you don't pay attention on these last two, you're going to hit something very confusing in the homework. So if you're working ahead because you understand this, make sure to pay attention when I do these last two.
Is it just like equations?
It's because the equations end up being different. Okay, so we know how to do this, so I'm going to run through the actual algebra part of this. So negative 2x plus 10 more equals negative 3x minus 6 plus x. We're going to combine our like terms on each side. So I already have 1x, so that's just negative 2x. Then we're going to add our numbers together, so plus 20. I'm going to combine my x's over here on the right, so that's negative 2x.
A 0 can't be negative. Where did you get 20?
10 plus 10.
Oh, wait. Oh, wait, why is that? Okay, sorry. I wrote a negative sign.
Oh, yeah, you're distributing a negative to a negative, so they canceled. So we combined our numbers, and over here we combined our letters, just so you know. Okay, we're going to subtract or undo our lower amount of x's. So let's do plus 2x, plus 2x. Those cancel, those actually cancel as well, and I have 20 equals negative 6. So our variable went away completely. If our variable ever goes away, all we have to do is answer if it's a true or a false statement.
It is false.
20 does not equal negative 6. So that is false. If it's false, that means that there is no solution to this problem. There is nothing I could put into x to make this work. Okay? Well, it's going to be a multiple choice. So it'll say enter your answer here. Unless it's no solution, click no solution. Okay? So there's no solution on that one. The last one. If we solve that one, we have to distribute. That ends up being 3x minus 12 equals 3x minus 12. Minus 3x to both sides.
This is going to be equal. It's going to be, yeah.
Negative 12 equals negative 12. If you scroll down to the next slide, it shows you what to put in that case, but this is true. If it's true, then your answer is all real numbers. That's something called an identity. So your answer is all real numbers if it equals. Okay, questions? Guys against the wall, you got any questions? You know what we're doing. So if I gave you one of these problems, you could get it right. Yep. Okay. All right. Okay. Is there anything you need me to explain? Anything we need to go back to? Anything at all? I promise in the end it will make it easier to get rid of those fractions. So don't just decide that this is too much work.